So today we're going to start section 4 of the prerequisite chapter. Today we're going to start factoring polynomials. The first thing we should always do whenever we're factoring any type of problem is always look for a greatest common factor first. So we will look for a GCF of both the coefficients and the variables. Now you probably did GCF way back in 4th grade, but it didn't include variables. It was probably just a GCF of numbers. When we're looking for a greatest common factor of variables, what we're looking for is the variable they both have in common, and we're looking for the smallest exponent. So what I need to do here is look for my greatest common factor between the numbers 6 and 4. So what I can do here, we can do a organized list here. So 1 times 6, 2 times 3, 4 is 1 times 4, 2 times 2. And then I'm going to look for the greatest factor that they both have. Notice they both have a 1, they both have a 2, and of those common factors, the greatest one that they both have is going to be the 2. Then I go back to look, do they both have the same variable? They both have the variable x. So the one that is in common is the smaller exponent, so it's just going to be the single x, or the x to the first. Now that I found my GCF of that binomial, it's actually going to be 2x. I'm going to take my binomial, and what I like to do, just to give myself a visual, is I like to write the GCF underneath each term. You don't have to do this. And then what we're doing is we're dividing both terms by that GCF. Now, what you need to do is you need to write the GCF. You're going to open a parenthesis, and then you're going to put the division of the 6x cubed divided by 2x. When I divide 6 by 2, I get 3. And remember, for the exponents, you subtract them. And then I'll divide 4x by 2x, and I just get a 2. So what goes in the parentheses is the division of the original polynomial, in this case it's a binomial, by the GCF. When you're writing your answer, you need to include the GCF out front. Now, one way you can check your answer is you could distribute the 2x back in, and if it goes back to the original problem, you've done it correctly. Now, if after you divide, and in this parenthesis, if there's still another GCF you could pull out, then chances are you didn't pull out the greatest common factor. And then I would go back and rework it. And I'm going to show you an example of maybe where you didn't pull a GCF out, the greatest. So let's try some examples. So whenever you're told to factor, your first step should always be to find and check and see if there's a greatest common factor. Can I divide all of the terms in my polynomial by the same number? So I'm going to go ahead and look at my 3 terms here in number 1. Notice they all have the common factor, the greatest common factor of a 4. Now, when we start factoring the trinomials, it's in your best interest to keep your squared term positive. So always try to keep x squared positive. So technically, I could pull out a GCF of this trinomial of just a 4, but what I'm actually going to factor out is a -4. So my GCF here is -4. I like to show what I'm dividing by to give myself a visual. So now you write the GCF down, and now in the parentheses is the answer to the division. So -4 divided by -4 is +1, but then we have the x squared, so +1x squared. 12x divided by -4 is going to be -3x. And then -16 divided by -4 gives me +4. What you would have had to do if you didn't recognize the factors of the numbers, so what I'm doing is I'm listing the factors of 4, 12, and 16. So 1 times 4, 1 times 12, 2 times 6, 3 times 4, 1 times 16, 2 times 8, 4 times 4, I'm looking for the greatest factor that they all have, and it was a 4. Technically, I could have also just done positive 4, but then I would have gotten a negative x squared, and then I would have gotten, let's see if I do negative, if I just do a positive 4, then it's a negative x squared, positive 3x, and then negative 4. This would have also been acceptable, but moving forward, when we start finding the zeros of our polynomials or the x-intercepts, you're going to want to leave that x squared positive. So technically on the test, since we're not there yet, either answer would be acceptable. But always try to pull out a GCF that will make your squared term positive. Because what we're going to see is after we pull out a GCF, if this trinomial that remains can still be factored, we have to keep going. But this one I cannot continue factoring. It's prime. It's done. So either answer here would be acceptable. I'm going to look at my greatest common factor between 3, 6, and 9. And I can see that GCF between 3, 6, and 9 is going to be 3. Notice all three terms also have the variable x. I'm going to look for the smallest exponent, which is just the single x. So my GCF here is going to be 3x. I'm going to divide all three terms by the GCF. I need to write the GCF, open the parentheses, and now I'm going to write the answer to each term's division. So 3x to the third divided by 3x is just x squared. Negative 6x squared divided by 3x is negative 2x. And then 9x divided by 3x is just 3. Sometimes your GCF may not be a monomial, it may be a binomial. Notice each of these terms, because this is a term here, this is a term. Notice both of them have in common the binomial x minus 2. So x minus 2 is my GCF. So what I'm going to do is write the GCF down, and now I have to put the division. Notice here, this is going to cancel, becomes a 1, so I'm left with 2x. Then over here, this one, same thing, and then I'm left with the 3. So your final answer is actually two binomials when it's factored. The next one, same thing. Now, notice it's a binomial squared here. So if it helps you to write this as x plus 3 and x plus 3, and then minus the 4 times x plus 3, the terms are what's separated by the addition or the subtraction signs. So these are my two terms. Notice they both have in common an x plus 3. That is my GCF. So again, I write the GCF down. And now in the parentheses is what remains after I divide. So from the purple one here, this becomes 1s. So I'm left with x plus 3. And then from the green, I'm left with minus 4. Let me write that in black so it shows up. Now, when there are like terms that you can combine, you need to combine them. So I can actually simplify this to an x minus 1. And you're done. So yesterday, when we were learning how to multiply binomials, we saw one of the special products. It was called the difference of two squares. So when two terms of a binomial are perfect squares with a minus sign in between them, this is your example of the difference of two squares. So in order to factor it, you're going to square root the first and the last terms. One of your parentheses, one of your binomials will get a plus sign, and the other gets a minus sign. You can always FOIL it to check it after you factor it to see if it goes back to your original problem. So notice in my example here, I have a subtraction sign in between two perfect squares. So whenever you see a binomial that has a subtraction sign, and if both terms are perfect squares, what we're going to do is square root the first term. So we're creating two binomials. So when I square root x squared, remember when you find an x squared, and again, a square root, the little index here is assumed to be a 2. So when I square root x squared, it'd do 2 divided by 2, and the square root of x squared is x. So I'm going to write an x here and an x here. Then I'm going to square root the second term, the 4, and I put a 2 here and a 2 here, because the square root of 4 is 2. And then one of the parentheses gets a plus sign, one gets a minus. It doesn't matter if you write the subtraction first and the addition second. Either answer is acceptable. Once you think you have your binomials, you can FOIL it to check it. If it doesn't go back after you FOIL to the original problem, you've done something wrong. So let's FOIL it. First, x squared. Outside, 2x. Inside, negative 2x. And finally, last, positive 4. Notice the inner and the outer canceled. So I'm left with x squared. Oh, I made a mistake. There should be a minus sign. There should be negative 4, because negative 2 times positive 2 is negative 4. And notice it did go back to my original problem. If it didn't, you factored it wrong. So just be careful. Now, one thing to note, notice the name, difference of two squares. So you will never be able to factor something that is the sum of two squares. There is no way to factor the sum of two perfect squares. There are no factors of 4 that will give me nothing. So you cannot factor the sum. It has to be a subtraction. Let's try some examples. Okay, now, what I would tell my Algebra 1 class when I taught Algebra 1, in order to make factoring the difference of two squares easy, I recommended that they always memorize the perfect squares up to 20. You should already know up to 12 from 3rd grade, because you learned your times tables. So you should already know 1 times 1, 2 times 2, 3 times 3, all the way up to 12 times 12. And then a matter of memorizing 13 times 13, 14. There's not that many. Now, a little fun fact about 13 and 14. When you square 13, it's 169. When you square 14, all you do is reverse the 6 and the 9, and it's 196. 20 squared is easy as well. 2 times 2 is 4, and then add 2 zeros. So really, there's not that many beyond 12 to focus on. But if you don't know them, then you're going to have to do, for example, 15 times 15 on your paper. If you needed to check a perfect square, that's actually 225. But let's go through and start looking at these examples. Now, always, always, always see if there's a GCF that you can divide out first. Now, for this one, there is no greatest common factor between 9 and 49. However, 9 is a perfect square, 9x squared. So I'm going to square root it. This is going to give me 3x and 3x. And then for the second term, square root it. I get 7 and 7. 1 gets a plus sign, 1 gets a minus. So when you see a binomial, as long as you recognize that they are perfect squares, just square root both numbers and put them into two binomials, one with an addition sign, one with a subtraction. And again, the order doesn't matter. I could have put the 3x minus 7 first. The next one, again, there is no GCF between 36 and 49, so I'm going to just square root. So I'll set up my binomials. Remember, one's going to get a plus sign, one gets a minus. I'm going to square root the 36x squared. It gives me 6x. That goes in the first spot. And then I square root the 49y squared. 7y and 7y. For the next one, when you look at this, you're going to think, wait, they're both perfect squares. However, always look for a GCF first. And my GCF here is going to be 4. And I'm going to show you what would have happened if you didn't pull out the GCF. So I'm going to first divide them both by 4. And then now write the GCF. And then what remains is going to be still the difference of 2 squares. So then now what I have to do is I write the GCF, but I square root the x squared, square root the 25, plus 5 minus 5. Now watch what would have happened. If you would have just left it like this and said, you know what? This is a perfect square, 2x. This is a perfect square, 10. Notice in the parentheses, you could have still found a GCF between 2 and 10. So as soon as you see there's still a GCF here, which is 2, you knew you did something wrong. Stop, go back, pull the GCF out first. If you give me this answer, it's wrong. Okay, it is not fully factored. So always, always look for a GCF first. Yes. Yes. Next one. Notice these are both perfect squares, but notice the symbol in between here. Remember, there is no way to factor the sum of 2 perfect squares. So what we would do is you would either say cannot factor, or you would just rewrite the problem. Some Algebra 1 classes tell you to write the word prime. I'm okay with just putting cannot factor or rewrite the original problem. Say we tried it. So let's say we said square root it and get 5x and 6, 5x and 6. If you put 2 plus signs in order to get a positive 36, so if I FOIL this, first gives me 25x squared, outside gives me 30x, inside gives me 30x, and last gives me 36. So once you combine these, it doesn't cancel, it gives you a middle term. So it does not go back to the original, so you can't factor it. Let's try the next one. Now, a lot of times when your exponent is going to be greater than a 2, you're going to have to factor more than once. So this is a perfect square. It is a subtraction. So what I'm going to do is I'm going to do the same thing. I'm going to square root this term, and I'm going to square root this term. So what I end up with, remember when you square root it, you're dividing the exponent by 2. So this becomes x to the 4th. And then the square root of 1 is 1. And then 1 gets a plus sign, 1 gets a minus. Now, notice I still have the difference of 2 squares here. So I got to keep going. This one's done. So I need to still keep breaking it down. But now I'm going to, again, do the same thing. Square root, square root. So then this will become x squared. And I write it and make my 2 binomials. And again, the square root of 1 is 1. 1's a plus sign, 1's a minus. I still have the difference of 2 squares on this last one. So I got to keep going. So again, the first 2 are done. I can't factor the sum anymore. But again, this one, square root, square root. So then this makes 2 binomials. Square root of x squared is x. And then the square root of 1 is 1. So 1 gets plus, 1 gets minus, and then a 1, and then a 1. And now you're finally done. So this is the full final answer. Same thing on the next one. 625 x to the 4th minus 1. These are both perfect squares. So I'm going to square root it, square root it. Square root of 625 is actually 25 times 25. So I'll put 25x to the second because 4 divided by 2 is 2. Square root of 1 is 1. 1 gets a plus sign, 1 gets a minus. I still have the difference of 2 squares over here. So I got to keep going on this one. This one you're just going to bring down. It's done. Can't factor the sum. And then again, square root, square root. Square root of 25x squared is 5x. Square root of 1 is 1. 1 gets a plus sign, 1 gets a minus. So 5x minus 1 and plus 1. And now you're done. Now, next one, it's backwards, but we can still factor it. Again, remember, the order of this doesn't matter. If you would have preferred to put the 25x squared minus 1 first and then break it down, these guys could have been written first and this at the end. Again, the order that you write these final factors doesn't matter. All right, the next one, number 11, 3 minus 12x squared. Again, look for a GCF. The other ones didn't have a GCF to pull out first. This one does. I can divide both of these by 3. That's my GCF. And now I'm left with 1 minus 4x squared. The difference of 2 squares. So I'm going to square root, square root. So then this becomes 3. And then I'm going to make my 2 binomials. Square root of 1 is 1. 1 gets a plus sign, 1 gets a minus, and then the square root of 4x squared is 2x. And you're done. So all I'm going to do on the next one, number 12, is it is the difference of 2 squares. So I'm going to square root the first one, square root the second one. So my 2 binomials, when I square root something that's squared, it just cancels the radical. So this becomes x plus 2, and then the square root of y squared is just y. 1 gets a plus sign, 1 gets a minus, and you're done. No like terms to combine. So x plus 2 plus y in the first trinomial, and then x plus 2 minus y in the second. And again, the order doesn't matter. Okay, so for number 13, these are still 2 perfect squares. So I'm just going to square root the first term, square root the second, and we'll set up our 2 binomials. So the square root of x minus 1 squared, the square root just cancels the square. So then this just becomes x minus 1. And then the square root of 9y to the 4th is going to be 3y squared. 1 gets a plus sign, 1 gets a minus. And notice I can't factor any further, so that would be your final answer. The next one, notice if you look at this, you're going to say, oh, they're both perfect squares. However, there is a GCF that you can factor out first. It will be 9. 81 divided by 9 is 9. And then 36 divided by 9 is going to be 4x squared. Still 2 perfect squares. So again, square root the 9, square root the 4x squared. Write the GCF, don't forget about it. And then the square root of 9 is 3. The square root of 4x squared is going to be 2x. 1 gets a plus sign, 1 gets a minus. And again, the order you write it doesn't matter. And then this one, I'm going to do the same thing. They are 2 perfect squares, and it is the difference. So I will square root the x to the 4th, and I get x squared. Square root the 16y squared, and I get 4y. Now, I cannot go any further because the y is not squared. The 4 is a perfect square, but the y is not. So this would be where we would stop. So perfect square trinomials. What we're going to do is we can do a test. We can square root the first and the last terms, then double that product. And if that gives you the middle term, then it's going to be a perfect square trinomial. And all you have to do is square root the first and the last terms, and then take the sign of the middle. If it does not give you that product, then what you're going to have to do is do it a long way. And that's what I'll show you after the test. So what the trick here is to do is I take the square root of the first term, so x, square root of the last term, and then double that. So x times 5 times 2 is 10x. And if it gives you the middle number, then you know it's a perfect square trinomial. And all you have to do is take the square root of the first term, square root of the second term, or the last term, sorry, put the sign of the middle, and then it's a binomial squared. You can also write your answer as x minus 5 times x minus 5. Either way is acceptable. So let's try some examples of these. So for 16, I'm going to do the test. I need to square root the first term, square root the last term. So the square root of 16x squared is 4x. The square root of 9 is 3. And then remember, you're going to double it. So 4x times 3 is 12x times 2, 24x. Because it gave me the middle number, this is a perfect square trinomial. So all we have to do is square root the first term, square root the last term, and put the sign of the middle. And it's a binomial squared. For number 17, same thing. I'm going to square root the first term, 3x, square root the last term, 5, double it. 3x times 5 is 15x times 2 is 30x, which is the middle. So now I just square root the first term, square root the last, and put the sign of the middle. And it's a binomial squared. Let's try the next one. Square root it, square root it. Now this is when the ends are perfect squares. So I end up with 2x. The square root of 1 is 1. Double it. I get 4x, which is the middle. So my answer is just going to be the first term square rooted with the sign of the middle, the last term square rooted, and then it's squared. Now this isn't always going to work. So for example, let's say the problem was x squared plus 13x plus 36. These are both perfect squares. If I square root this and this, I end up with x. The square root of 36 is 6. And if I double it, notice I get 12x. That was not the number in the middle. So what we're going to learn after the test is we will list the factors of 36. That will give me 13. And this is actually going to factor into x plus 4 and x plus 9. But that's coming up later. For now, you're just doing the test to see if it's a perfect square trinomial. And if it is, then your answer is a binomial squared. 2 more examples. So if you're good at recognizing the perfect squares, square root, otherwise you have to do it the long way. And that's coming up. So the square root of 36y squared is 6y. The square root of 49 is 7. Double it. 42 times 2 is 84y. It is the middle. So just take the square root of the first term, the last term, give it the sign of the middle, and square the binomial. And then this one, we're going to square root. They're both perfect squares. The square root of 9u squared is 3u. The square root of 16v squared is 4v. Double it. 3 times 4, 12, times 2, 24, and then it's got the uv, which is the middle. This is missing a v. Add a v here. It is the middle. It's a typo. So then just square root 3u, 4v, sign of the middle, and square it.